Hey folks, I am Jerry Mounsey. I would like to thank you for joining us today. Focused on developing a streamlined, efficient process, we would like you to join us in our sustainability campaign. Corrugated packaging is the most recovered packaging material on the planet and is a leader of creating a circular economy. But traditional plates that print them can leave a long-lasting environmental footprint. True sustainability doesn't stop at corrugated board. True sustainability requires looking at the entire production cycle, which begins with the printing plate materials used to reproduce images. Traditional flexographic printing plates often rely on harsh solvents that create VOCs and are energy intensive when processing polymers. Transitioning to thinner plates on highly resilient foams that incorporate recycled photopolymer have many benefits, as you will see in this video. We'd like to welcome you to join Sustainable Solutionz in our mission of doing well by doing good.
For decades, North American corrugated facilities have relied on 250 plates mounted on 30-point PVC. A year-long collaboration between Clemson University and Sustainable Solutionz tested whether that standard could be replaced, working with 16 printing facilities across the United States. 83% of samples demonstrated improved or equal print quality when transitioning to 155 plates on RENUflex backing material. The opportunity in front of us now is a vertically integrated supply chain where plate waste becomes new product, closing the loop entirely. This video walks you through that process, from initial plate mounting through a live press run, so you can see exactly how it works. Start by laying the photopolymer plate flat on the transfer table. Remove cover film, engage lever, and create a reverse half moon. Slide plate into laser, turn vacuum on, move plate into tunnel. When the top of the frame comes down, the bottom lamps will engage to expose the polymer where the laser has ablated the carbon layer, creating the desired relief. Followed by that, the upper lamps will expose the face of the plate to cross-link the polymer, which solidifies the images. In example, the thinner the plate, the better the resolution. Plate is punched and then attached to the lead edge pins. The lead edge bar pulls the plate through the washout unit. Removal of plate from washout unit. Remove the lead edge bar from plate, then wipe image face to remove any residual polymer prior to plate drying. Transfer the plate into the dryer to eliminate swelling. Followed by drying, UV source engages to eliminate plate tack and cure photopolymer. Adhesive activator ensures a strong bond between the PET substrate and sticky back. Preparing to adhere sticky back to PET substrate. Plotting and cutting plates prior to mounting. The RENUflex backing material is cut to specification using the CNC machine, ensuring precise, consistent sizing across every plate. Notice the plate being secured to the RENUflex backing by adhering the adhesive to the mylar substrate. With the plate mounted to the RENUflex backing material, it's ready for storage. Plates hang vertically on racks, and one of the advantages you'll notice immediately is how flat and straight they hang. RENUflex resists the curl that is common with traditional PVC-based backing materials, making storage efficient, more organized, and easier to manage. It's highly recommended to have UV filters located in the dye room in order to protect the integrity of the photo-initiated plates. The mounted plate is then secured to the cylinder, preparing it for the OptiCheck proofing process. Once plates are etched, the used solvent doesn't have to go to waste. Distillation units recover up to 95% of developer solvent, separating it from polymer residue so it can be blended with virgin solvent and reused. Less waste, lower costs, consistent plate development. With plate making complete, it's time to move to press. To establish a performance baseline, the first run uses a 250 plate adhered to 30-point PVC and secured to the plate cylinder with the RENUstrip lead edge. This gives us a direct reference point before running the 155 plate mounted on 122 RENUflex. The trail edge of the plate is secured to the cylinder, tape is used here for speed, though tension bands are equally effective depending on your shop's preference and workflow. With the plate secured, the ink system is brought online. Ink is fed through a pump and bucket dispensing system, circulating continuously to maintain consistent flow and temperature throughout the run. Before printing begins, viscosity is checked to confirm the ink is within the correct range for the substrate and print conditions. Proper viscosity and pH are critical to achieving clean, consistent print quality across the full run. Corrugated board is loaded into the hopper, staging the substrate for the press run. Consistent, properly aligned loading at this stage helps ensure continuity and reduces the risk of misregistration on press. The corrugated sheets are inserted into the hopper. From there, the board is transferred into the printing deck, and from there, through the rotary die cutting station. The top cylinder shows the cutting die, which slots, perforates, scores, cuts, and ejects skeletal material from the board into the evacuation system. The bottom cylinder acts as the blanket, providing the surface against which the die makes its cut. This process shapes each corrugated sheet to its final dimensions as it moves through the press. The first sheet off of the press is pulled for inspection. This lead sheet provides the operator the visual perspective on how the plate is reproducing the image. At this time, the operator checks type, font, and screening to determine whether plate and analox impression adjustments are needed prior to commencing the press run. At this point, preliminary production commences by producing roughly 30 sheets. The operator then determines if any additional plate or analox adjustment or plate cleaning is necessary prior to producing board. Once validated, the images reflect the print card and production is initiated. Once the run is complete, the operator carefully demounts the 250 plate from the cylinder. The mounts are removed, cleaned, and stored for the next production run. The operator then mounts the 155 plate on 122 RENUflex, as this will be used as a comparison between the 250 print results. As with the first sheet from the 250 plate, the 155 plate sample is pulled for inspection. This initial sheet gives the operator an idea of how the plate reproduction looks, checking type, font, and screening. This helps the press operator to determine whether any analox or plate impression adjustments are needed before the run commences. Clemson University's independent study compared 155 plates on RENUflex against the traditional 250 plate standard across 16 facilities and 18 sample sets. 83% of samples showed improved or equal print quality across every substrate type tested. It should be noted that the few locations that did not show improvement was because the press team ran out of time to make adjustments prior to running the 155 plates for comparative testing on 3 of the 18 press runs. Holding the 2 plates side by side tells its own story. The 250 plate shows a noticeable curl, while the 155 RENUflex backed plate hangs flat and straight. The weight difference is just as apparent. The 155 mount is 32% lighter than the 250 mount, and consequently improves ergonomics. RENUflex and RENUstrip are built differently from the ground up. The urethane is cast directly to the mylar substrate, not laminated, which eliminates the water intrusion and delamination risks that come with adhesive lamination. The microcellular foam is water-resistant, highly resistant to compression set, and delivers superior resiliency press run after press run. At approximately 32% lighter than 250 plates, it's easier on your operators and it reduces board crush in the process. You'll also see reduced VOCs and solvent consumption, less plate finishing time, and a transition that fits seamlessly into your existing workflow. Enhanced image reproduction, a dimensionally stable 14mm mylar substrate, repurposed photopolymer granules built right into the urethane and manufactured right here in the USA. And when the job is done, your plates, backing, and locking strips are 100% recyclable at end of life. The shift from 250 to 155 plates isn't just a process change. It's a step toward an absolute circular supply chain, one where nothing goes to landfill and all material components have a next life. The path is proven, the transition is seamless. Join us in making the impact that moves the whole industry forward.